Hello. We've already explored SRv6, a key IPv6 enhanced technology. Today, we're joined by Jimmy Dong, an expert from Huawei's Data Communication Standard and Patent Department, who's going to help us explore another important feature of IPv6 enhanced: network slicing.
Hi everyone, it's good to be here.
Jimmy, can you tell us what network slicing actually is?
Sure, let's use a real-life example to help us understand this concept. During peak hours, in both the morning and evening, you're likely to get stuck in rush hour traffic during your commute to and from work. To ensure that emergency vehicles like ambulances and fire trucks don't suffer the same fate, many authorities provide dedicated emergency lanes, reserved exclusively for them. And networks are similar. With the emergence of 5G in the cloud, networks are carrying more and more types of services and require much higher bandwidth. Network congestion is therefore more likely to occur, potentially affecting the performance of key services, those ambulances and fire trucks. So network slicing is used to construct multiple, dedicated, virtualized, and isolated logical networks for different services over a general-purpose physical network. The technology meets the different needs of different services in terms of network capabilities and resources, ensuring service performance.
Can network slicing eliminate network congestion then?
Network slicing can't increase the total bandwidth of a network. When the total traffic entering the network is greater than the available bandwidth, congestion will still occur, of course. However, with services in different slices isolated from each other, network slicing prevents service bursts and congestion in one slice from deteriorating the performance of other services on the same network, but in different slices. This is similar to using VLANs to confine the scope of broadcast storms. When impact between network slices is eliminated, predictable and guaranteed performance can be provided for services. So, although network slicing doesn't eliminate congestion, it does ensure the experience of certain services, even when congestion impacts other parts of the network.
When did this concept of network slicing first emerge?
The concept dates back to around 2015.
And what were the drivers for its development?
It emerged with the development of 5G and its new needs and architecture. 5G defines three typical service types: EMBB, URLLC, and MMTC. Each has different network needs. So, to carry them all on a single network, 5G standards and industry organizations proposed this concept of network slicing. A 5G E2E network slice has three parts: radio access, mobile core, and transport network slices. The transport network slice is actually the IPv6 network slice we're talking about today. It mainly provides on-demand NE connections between the access and core networks, guaranteeing service performance. This transport network slice is therefore an essential part of a 5G E2E network slice. Given that 5G is one of the major uses for transport network slices, we're seeing them being put into use in more and more industries and applications. And they must be able to offer differentiated services, resource and security isolation, and automatic O&M.
So network slicing is a product of 5G's arrival. Before network slicing emerged, what technologies did we use to provide different service guarantees?
We mainly used QoS to provide differentiated services and used VPN to provide service isolation. But this is just a basic level of differentiation. And due to the best effort characteristics of IP networks, network resources are still shared, so service performance might not actually be guaranteed.
So VPN technology was put into commercial use before network slicing. What's the difference between VPN and network slicing?
VPN controls the connections and access between service access points. It isolates services or users. Network slicing realizes resource isolation on the basis of user and service isolation. To provide guaranteed service performance, 5G E2E slicing requires resource isolation on the access network, transport network, and core network. Network slicing also requires lifecycle management of user slice services as well as the extension and enhancement of a series of control protocols. Building on this, network slicing is an architectural innovation at the network level. So it's only achievable after the introduction of new technologies or protocols to the forwarding, control, and management planes.
Is there any instance where network slicing is a must-have on the live network?
Network slicing is a business-driven solution. It provides E2E fine-grained resource guarantees and differentiated services. Traditional IP networks, in contrast, provide only best effort services and can neither provide sufficient differentiation capabilities nor ensure service performance. For this reason, network slicing is able to satisfy the requirements of many new services. For some industry players, power grid and port enterprises, for example, we can provide network slicing to implement hard isolation of resources, replacing the SDH-like dedicated private networks used before.
What is the difference between network slicing and dedicated private networks?
A dedicated private network is a physical network built using standalone network devices for a specific purpose. It meets the needs of a single service and no more, and it involves both high deployment and O&M costs. That makes this type of network suitable only for a small number of customers and services. Network slicing, on the other hand, meets the different requirements of diverse customers and services by providing different logical networks over one public network. In short, network slicing provides service performance similar to a dedicated private network, but at a much lower cost. As a result, many dedicated private network users are now thinking about migrating to network slices.
Great. Thank you, Jimmy. And thank you for watching.